and our paper is entitled Resolution Enhancement in Single Depth Map and Aligned Image. So high resolution or high quality depth maps are crucial for many applications. And due to the limitations of the depth sensors, and depth maps suffer from two things. The first one is low spatial resolution, especially when the object is far away from the camera. And the other thing is missing depth values. It may be caused by different reasons, such as short distance between the object and the camera, disparity between the projector and the sensor, and poor reflection of the light patterns. And currently, the depth super-resolution mainly falls into two categories. The first one is about multi-frame super-resolution, and the other one would be single-frame super-resolution, but with the assistance of a high-resolution RGB image. So here, the first contribution of our paper is we consider the situation where we only have one pair of low-resolution inputs. And the second contribution will be we present a novel depth completion scheme by exploring the dependencies between the input pair. And the third one is we adopt external example-based learning pipeline to train the regression models for the super resolution purpose. And finally, we have very good performance both numerically and visually. Okay, just very briefly go over our framework. This is a sequential framework. So the first part is depth completion. So we use an exemplar-based impending process. Here, we just want to make sure that we have the correct label map before the impending process. So the label map is used to differentiate between the object, foreground object, and the background scene. And this is done through a SBM classifier. So that leads to another question: how do we get the training data? And here, we just use the depth input to label a part of the training data, and this is based on a simple assumption that the top n pixels that are closest to the camera would be foreground object, and the top n pixels that are farthest from the camera would be the background scene. And then we train a classifier to get the label map, and during the impending process we just use the pixels, non-pixels with the same label to do the prediction. And for the super resolution, so here for both the depth maps and the intensity images, we follow the same training pipeline but with different kind of training exemplars. And here to ensure target learning process, we first model the input feature space with Gaussian mixture models, and for each Gaussian component we train an individual regression model. And during the testing phase, once we have a patch-based feature, we find the Gaussian component it belongs to and apply the corresponding regression model to perform the upsampling. So just a preview, sorry for the resolution, just for a preview of our results. For more results, please stop by our poster, and I'm waiting there for you. Thank you.